Welcome everyone to today's deep dive into the awe-inspiring life cycle of stars. Stars are not just distant points of light, they are dynamic entities that undergo incredible transformations over billions of years. Today, we'll explore how stars are born, evolve through different stages, and ultimately meet their end in spectacular fashion. Stars begin their journey within vast clouds of gas and dust known as nebulae. These clouds primarily consist of hydrogen and helium, the fundamental building blocks of stars. Gravitational forces within these nebulae cause regions to collapse under their own weight, forming dense cores called protostars. These protostars are surrounded by swirling disks of gas and dust, from which they continue to accrete mass. Over tens of thousands to millions of years, depending on their mass, protostars grow hotter and denser as they accumulate material from their surrounding disks. The pivotal moment in a star's life occurs when the core temperature of the protostar reaches approximately 10 million degrees Celsius. At this temperature, nuclear fusion reactions ignite within the core. Nuclear fusion is the process by which hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the form of light and heat. This energy creates outward pressure that counteracts the inward pull of gravity. This delicate balance between gravity and pressure marks the birth of a star and its entry into the main sequence stage. Stars like our Sun spend the majority of their lives in this stable phase, steadily converting hydrogen into helium in their cores through nuclear fusion. The evolutionary path of a star is primarily determined by its initial mass. Low to medium mass stars, such as our Sun, will spend billions of years steadily burning through their hydrogen fuel. As hydrogen in the core depletes, the balance shifts. The core contracts while the outer layers expand, causing the star to evolve into a red giant or supergiant. During this phase, stars can expand to many times their original size, engulfing inner planets in some cases. Red giants and supergiants are incredibly luminous, radiating vast amounts of energy into space. They also play a crucial role in enriching the universe with heavier elements synthesized during their lifetimes. The fate of a star ultimately hinges on its mass. Low to medium mass stars, after shedding their outer layers as planetary nebulae, leave behind a dense core known as a white dwarf, a hot, Earth-sized remnant that gradually cools over billions of years. Higher mass stars, however, meet a more dramatic end. When these massive stars exhaust their nuclear fuel, they can no longer sustain fusion reactions to counteract gravity's inward pull. The core collapses under its own weight, triggering a cataclysmic supernova explosion. Supernovae are among the most energetic events in the universe, briefly outshining entire galaxies and dispersing elements forged in the star's core into space. Depending on the mass of the original star, the remnants of a supernova can include neutron stars, dense stellar corpses composed almost entirely of neutrons, or black holes, regions of space where gravity is so intense that not even light can escape. Thank you for joining me on this incredible journey through the life cycle of stars, from their humble beginnings in nebulae to their explosive ends as supernovae or serene fates as white dwarfs. Understanding the life cycle of stars not only sheds light on the workings of the cosmos but also underscores our place in the universe. If you found this exploration of stellar evolution enlightening, please like, subscribe, and share your thoughts in the comments below. Also, let me know what other cosmic topics you'd like to explore in future videos. Until next time, keep looking up at the stars and marveling at the wonders of the universe.